Now we are discussing the functions. Now this is a very important topic. Function is very important topic. If you are planning for engineering or later mathematics you want to take, then this topic is going to come again and again. So we are trying to study or read the special type of relation which is called the function. We have already known about relationship or relation. So function is nothing but a relation. It is a specific or special type of relation. As I said, it is important to mathematics, and there is a rule. There has to be some rule which signifies the new elements, or it will give you new elements. We'll see how. Various terms are there like map or mapping. These are used to denote a function, and I'll show how mapping is this. So a relation f from set A to set B is said to be a function if every element of set A has only one and only one image in set B. So if this is a set A, this is your set B. See, there can be no two element in A which can have a same, means one element of set A cannot have multiple images. So set A, the element of set A has to have only one and only one image in B. Otherwise it will not be a function. It may be a relation, it may not be a function. In other words, this function f is a relationship from non-empty set A to a non-empty set B, such that the domain of A means this is domain, this is range. So domain of A will not have any two distinct ordered pairs of f with the element as the first element, means you cannot have that element again and again. It has to appear only once. We'll see in the example, don't worry about this. If f is a relationship from A to B, we'll write A comma B belongs to f if fa is B. That means if you place any value here in A, you'll get only one value, B. So B is called the image of A under f, and A is known as, or it is called as the pre-image of B under f. So the function f from A to B is denoted by, this is the mapping. This is actually the mapping. This arrow which you see here is the mapping. So this f from A to B is denoted by f colon A to B. And we have seen in earlier discussion that some functions were some relations were functions, but some were not, and we'll see how. Let us start with an example. This is an example. So n is the set of natural numbers, and the relationship or relation R is defined on this natural number such that this R is xy, where y is equal to 2x. X and y belongs to R. So y is equal to 2x. What does it mean? And we also have to find out the domain, codomain, and range of R. And we have to find out also that is this relation a function. So the domain of R is the set of natural numbers as it is given. You can give any value here, means x. You can give any value in this x. The codomain is again a natural number n, but the range is what? See, it is multiplied by 2. So the value which is going to come will only be even numbers. So the range is the even natural numbers. And since every natural number n has only one and one image, see, you can you imagine any value which gives you two eyes? Can it be possible? No. So this relation is a function. Let us take one more example. You have to find out, these are the question, that whether it is a function or not. Whether it is a function or not. So first is R 2, 1, 3, 1, 4, 2. As I just indicated here, that this line, when I was explaining, I said, don't worry, we are going to revisit. So just understand what I am trying to speak. This relationship has 2, this is 2, 3 and 4 as first values. The second value can be repeated, but the first value cannot be repeated. So this R first one is not a relation. Let us come to the second one. Here see, the first one is 2 2, second one is 2 4. The first member is 2, which is repeated again, and this is not going to happen when you talk about a function. So a 2 is having value as, so see 2 is here, it is having a value, or it is giving a value 2 sometime, it is giving a value 4 sometime. It is not possible in a relation. In a function relation it is possible. Third one, 1 2 2 3 3 4 4 5 5 6 6 7, no problem, because every element has one and only one image, so this relation is a function. Let us take a definition now. A function which has either R, this R, or one of its subsets as its range, means a function which has this relation R or any subset of this R as its range is called real valued function. You can further also understand that if its domain is also either R or a subset of R, it is called a real function. So let us take an example how, or let me introduce you with this real function, or real valued function. Let n be the set of natural number. Just define a real valued function. So this real valued function is defined by f colon n to n, where fx is equal to 2x plus 1. So let us place 1 here. In this let us place 1. So this will be 2 into 1 plus 1, that will be 3. F1 will be 3. Let us place 2 here. So that will be 2 into 2 plus 1. F2 equal to 5. So this is the real valued function. Next is, let us take some functions and their graphs. First is the identity function. Identity function is written like this: y is equal to x. Why it is called identity function? Because whatever value you give in the x, y is going to assume that very value, that value only. So identity function we can formalize it like this: let R be the set of real numbers. We define the real valued function like this: f colon R to R. This is the mapping from R, that is real numbers, to real number. What I am speaking is the input is real number, output is real number, but we'll talk about the domain and range. So domain range is different. So y is equal to fx. What fx is? Y is x. So y is x means whatever value you give in x, it is going to get the value y. X is equal to y. So such function is called identity function. You see, 2, if you give 2 x into, you will get y2. You give minus 8, you will get minus 8. This is identity. So the domain and range will be R, because it is assuming the same value. Both x and y are same. So the graph is a straight line, as you see here, passing through the origin. The next is the constant function. Constant function is what? It is going to assume, is y is going to assume a constant value. It will not be dependent on x. You give whatever value to x, it is not going to accept, because it will give only, it will point to a constant value. So we define a function, this function f R to R, y is equal to fx, where fx is equal to c. So this is constant. So c is a constant, and for all which x, because whatever value you give x that belongs to R, you're going to get finally y. So the domain of R is what? R means domain, you can give any R value, but the range means the output value will always be constant. So this will be always constant. You can find here that if I give 4, first see this function, fx equal to 3. This is the function. So if I give 4, it will be 3. If I give 8, it will be 3. Always it will be 3. So this is the constant function. So the graph is actually parallel to x-axis and fx equal to 3. This is how the constant function is. Now we come to the polynomial function. Polynomial function is defined like this: a function f colon R to R. This is said to be a polynomial function if for each x which is belonging to this R real number, fx has to be, means y is equal to fx, y will be equal to a0 plus a1x plus a2x square plus an dot 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 an x to the power n. One thing you need to know, this n, the power here, this n cannot be, first of all, it cannot be non-negative, and then it has to be non-negative integer. So if you say x cube minus x square plus 2, this is a function, correct? X to the power 4 plus root 2x, it is a function, no problem. But if you say this is a function, no, this will not be a function. Why? Because the power is 2 to the power 3 and this will only take non-negative integers. This is not an integer. Let us take one more example. We want to define a function f, r to r, which is y is equal to fx. It is giving you value x square. So let us first complete the table, then we'll find out other things. So minus 4 you give, what you'll get? Minus 4, 4 4 is 16. So you get 16 here. Like this, you take 3, so you will get 3 is a 9. This is actually a square function. This is the complete table. And the domain of f, you can give any value. So domain will always be f. What about the range? Range also is, there is no specific value. These are all in the real number. These are all real numbers. So the range of f, actually you can write it like this, x square, such that x belongs to R, but the domain and range will belong to R. And the function is like this. This is like a conic section. Okay. So how you are going to get this? See, whenever you square any value, that is, you are not going to get any negative value. So this graph will always be above x-axis. It will never come below this x-axis. It will always be above. And second thing is, the value which you give, it goes somewhat like exponential. Not exponential exactly, but because it is squared. If cube, if you assume this could be y is equal to x cube, this graph would have been more skewed. But for right now, if you give value as 2, you'll get 4. You give value as 4, you'll get 16, like this. So this is how the graph is going to be. So we'll take a few more graphs and enhance our discussion. So till the time, thank you so much. Take care.